In the last video, we looked at these two different equivalent formulas for working out the variance. What we're going to do in this video is prove that these two formulas are the same. So you don't actually need to know how to do this, but if you're interested, then you can watch this video. So remember that this formula SXX is the sum of the squared differences of each x value to the x bar. So we could write that as our two formulas for variance is the sum of x minus x bar squared divided by n, and we've got our equivalent formula, which is the sum of the squared x values over n minus x bar squared. So let's try and prove that these two formulas are the same as each other. So let's start with the original formula that we had on the left hand side, and we'll try and end up with the formula on the right hand side. In order to do this, we need to know some facts about sigma notation or sums. So the first fact that we know is that if we're summing xi plus yi, and we're doing that for I values from 1 up to n, then what this actually means is that we're going to sub in I equals 1, so we'll have x1 plus y1, and then we'd add on, what do we get when we sub in I equals 2? So we'd have x2 plus y2 plus all the way up to subbing in I equals n, so we'd have xn plus yn. Well, we can rearrange this, and this is exactly the same as adding up all the x values and adding up all the y values separately and then adding those two separate sums together. So let's just write that out. So we could rearrange this to write that as x1 plus x2 all the way up to xn plus y1 plus y2 all the way up to yn. So we can actually split this sum up into two separate sums. We can split it up into the sum of each of the x's plus the sum of each of the y's, and we're going to use that in our proof. The second fact that we need to know in order to do this proof is if I've got the sum of a constant, so let's say a is a constant, and I'm timesing that by a function of I, say xi, and I want to sum from I equals 1 up to n, then what we're going to learn is that actually we can take things that aren't to do with I outside of the sum. So let's write out what the sum actually is. So this sum would be, sub in I equals 1, we'd have a x1, we'd add on, sub in I equals 2, ax2, plus all the way up to subbing in I equals n, so we'd have axn. And we can take the a outside of the bracket, and we can write that as a bracket x1 plus x2 plus all the way up to xn. So actually we've seen that we can take the a outside of the sum, and we could just write that as a times by the sum of each of the x values. So using those two facts, let's go on to prove that these two variance formulas are the same. So let's expand the double bracket inside the sum. So we're going to have, it's the sum of x squared minus 2 lots of x bar and then plus x bar squared. And all of that is still divided by n. So we're going to use fact 1 that we can split this sum up into 3 separate sums. So that's equivalent to the sum of x squared plus the sum of minus 2 x bar and plus the sum of x bar squared. And all of that is still divided by n. Well, there's nothing that we can do to simplify this first term in the numerator, so we'll just leave that as the sum of the squared x values. Now we're going to use fact 2 that we can take anything that isn't to do with I, because remember I is going from 1 up to n. We can take anything that isn't to do with I outside of the sum. So in this case we can take minus 2 x bar outside of the sum. So we'd have minus 2 x bar, and inside the sum we'd still have the xi, and that's going from 1 up to n. And then finally, this last term in the numerator, that's the sum from I equals 1 up to n of x bar squared. Well, x bar squared is just a constant. So if we sub in I equals 1 into x bar squared, we just get x bar squared. If we sub in I equals 2, we just get x bar squared, plus all the way up to subbing in I equals n, but if I sub in I equals n, I still get x bar squared. I doesn't affect it. So we're going to have n lots of x bar squared. So that's n x bar squared. So plus n x bar squared. And all of this is still divided by n. So let's split this up into 3 different terms by dividing through by n. So we're going to have the sum of the squared x values over n minus 2 x bar, and I'm going to write this as the sum of x over n, and plus, if I divide the last term by n, let's get x bar squared. Well, there's nothing I can do with this first term to simplify it. So let's leave it like, sorry, not an x bar over n. And notice that this fraction here, the sum of x over n, is just x bar. So actually this middle term is minus 2 x bar squared, because remember that x bar is the sum of x over n. And then plus x bar squared. So if we simplify that, we're going to get that the variance is equal to the sum of the x squared over n. And then we've got minus 2 lots of x bar squared plus an x bar squared. So we've got minus x bar squared. And that's where the formula comes from for the second formula. So we've shown that those two formulas are equivalent to each other.